right, let's see if I reach this microphone. Okay, so thank you for that introduction. I'm Lars Wikman, as mentioned, and I need a little bit of help. So I need a show of hands. Who has seen or read any of my work before? All right. Who here has listened to Beam Radio? All right. Who knows that I help companies recruit Elixir developers? Sweet. It's a tricky thing doing things online. You get very little feedback on the specifics of what you're doing, especially podcasts, because there's no mechanism for feedback there. Cool. So I run the Underjord site, but I also run a small consultancy. My team is over there and over there. Say hi. They're also on the slide. And if you need any reinforcements with your Elixir projects, we are happy to talk. It's just reach out. But that's not what this talk is about. This talk is an evolution of something I've been trying to do since the 90s. So, since the 90s, I got into computers and I started programming. First ran into C++, and that's when I got internet access, and I've been trying to get computers to do what I want since then. I have even ran into HTML. And I never did computer science. I'm entirely self-taught, and I've learned by building things. So when I started with C++, I went by the book, and I built some client or command line applications, very cool, like files and writing inputs and stuff. It was very impressive. And then it tried to tell me about objects. And I thought, finally, I'm going to get to put something on the screen. I can build something cool like Microsoft Office Publisher. And it didn't happen. They were talking about some other type of object, so I dropped C++, garbage language. Then I learned about HTML, and it was super easy to put buttons on the screen. Clearly, a superior programming language. Now, as I've run around just building whatever tickles my fancy, I have run into, over and over again, things that are just frustratingly hard to do. And it's been a little bit unclear to me whether that is because cool things are naturally hard to do, or hard things are naturally cool. But I keep wanting to do cool things with software, so I keep running into difficult problems. And to talk about a little bit about how I tackle building things, experimenting and learning, I think we need to figure out a theory of cool software. This is absolutely a pause for effect, and not just me hoping that the machine learning model will do the right thing. I have fallbacks. Slide forward. Rough. There's an arrow key. So, I posit in my theory that to make cool software, you need to take an input or generate some kind of input, and then you need to transform it. Then you need to produce a different but also interesting output. Now, this can describe almost any piece of software, so we need to take it a bit further. It will also need to produce an emotional reaction in a person. So, surprise, delight, anger, happiness. Sometimes it can be just one person. It can be you. Sometimes writing cool software is kind of lonely. But yeah, it's necessary. But that's not quite enough. Not all pieces of software that cover this ground qualifies. So what does qualify as cool software? Cool is contextual. It's in the eye of the beholder. So anything that you know currently or is kind of learning but haven't fully grokked yet has the potential to be cool. Things that are way outside of your league still, kind of, you don't have the experience to grok, or you really don't have the interest in, they have a hard time being cool. Something can be kind of too advanced to be cool. Things that you are just about ready to learn, and you kind of got the big picture concepts, and you're ready to dive into, that has a pretty good chance of being cool. And the things that you know really, really well, the things you do every day, they're not cool to you. Take the CRUD app, for example. When you build like 5 to 10 of those, oh, excellent, an alarm. When you build 5 to 10 CRUD apps, they stop being cool. But to the person building their very first app, they're magic. So, because we're all very serious professional developers here, right? Very, very serious. We sort of look down on chasing the shiny thing. It's very immature. You shouldn't do it. It's bad. I kind of want to argue in defense of chasing the shiny thing. Because just by definition, whenever you're trying to do something that you feel is cool, you are exerting yourself. You are trying something that you don't currently know. I think there's a lot of value in that. No one that I've heard of picks up the guitar and goes, I want to play dependable chords in a repeatable and reliable fashion. That's my goal. People pick up the guitar because they want to play a cool song or make music. And learning how to play an instrument takes years of active practice. Anything that serves as motivation to keep going and keep practicing has a lot of value in that context. Programming is the absolute very same. It takes years of practice for the skill to become effortless. Now, as you grow in experience, many developers start to apply constraints to their craft, and kind of for sport, or they get into like distributed systems, formal methods, or zero trust computing, or what do I know, code golf. Or they go for like the hardest problems of all, which is the human side, like management. But then they stop coding. I don't really do this for sport. I just want to build things, and I don't want to be a manager really, because I want to do coding. So I build these experiments and I keep trying to learn things. But why do that in Elixir? So I find Elixir to be kind of exceptional at dealing with inputs, transformations, and outputs. So you can do all the normal ones. You can do like APIs, and you can do your web hooks, and you can do your files and your web forms. But since I've started with Elixir, I've also explored things I never thought I'd poke around with. So input events on Linux, like raw, low-level input events, USB HID devices, chatbots as UI, hardware with sensors and buttons. And it all follows the same pattern. It all uses the same abstractions. The act of pulling an API for updates has never met a friendlier and more useful abstraction than the Gen server, because almost every time you want to talk to an API, you also need to keep track of a bunch of states, like your auth status, or the previous result to figure out if something new is happening, or the rate limits. And the Gen server just lets you bring that straight in. You don't have to add like a database and validation and schemas and yada, yada, yada. You get this really lightweight, really easy to prototype approach. And often the prototype lasts all the way to production, as we all know. So it also brings us Phoenix, which, it's a nice web framework. It does everything I need it to do. But I particularly like Phoenix PubSub. because that gives me a standard way of saying, oh, I got this input here. I'll throw it out to whomever it may concern. I don't really care where it's going right now. I'm working on the input. But it's got to go somewhere, so it goes to a topic, a Phoenix Pub sort of thing. This loose coupling makes it very easy to wire together inputs, transformations, and outputs. And building on the beam, I don't really need to bring in extra things like RabbitMQ or Redis. So I can stick to whatever the beam gives me. I don't need to spin up any worker processes at the OS level. The beam has everything I need in that regard. Now, for output, we have been given a great gift. We have been given LiveView. It's hard to communicate the difference between the past before LiveView and how much less work it is to just communicate something and build a live web UI that reacts to new information. All it takes, some familiarity with HTML, CSS, and usually a sprinkling of JavaScript. And it is also a mean source of inputs. You can do anything essentially the browser requires of you. So where does membrane come into the picture? It struggles with this one. Slide forward. Thank you, Whisper. So, examples of inputs and outputs. So I recommend everyone look at Erlang's WX library. It's a weird one, but it allows you to do cross-platform, desktop, native applications, and that's kind of neat. Then we have, of course, Livebook that everyone has already talked about, which apparently, beyond being collaborative code notebooks and great for teaching, now you apparently can just ship those as apps to different providers. So there's a lot of energy behind Livebook, let's just say. Then there are, of course, chatbots, which I mentioned. So Slack, Discord, Telegram, pretty easy to integrate with, all in all. And of course, if you need to deal with hardware, so sensors, buttons, displays, you can work with nerves, which I rather like. So personally, on my desk at home, I have this calendar gadget. So it's an e-ink display strapped to a Raspberry Pi Zero, and it shows me what my next calendar event is and my current calendar event is. Pretty straightforward, honestly, but actually kind of useful and very unobtrusive. I have also built like a macro pad, which is a small keyboard that I use to control lights in my office. Now, both of those have been almost deprecated because I bought a Elgato Stream Deck Plus. I don't know if you've seen these devices. You get 8 keys that are also programmable LCDs. And you get this LCD touch strip that you also get control over. And then you get 4 knobs that you can do twisty things with. So control your volume, your lights, whatever. And they also click. So you get all this stuff and you can control it from Elixir, or at least you can if you're stupid enough to. There was not a library originally, okay? And the default software does not support Linux. There are some open source options, but of course I decided to build my own. At last year's ElixirConf Africa, I also talked about chatbots as UI. And at that point I was shelling out to Python to get kind of some neat responses to my chatbots. And yeah, those are some examples of kind of what I've been doing with inputs and outputs. So, membrane. I think the slides got out of order, but that's okay. Now, if you've ever done audio or video on the web, you know that it's difficult, you know that it's hard, it's frustrating, you're dealing with opaque formats. So what you do is you grab a FFmpeg and you go and Google Smith your way to this command line piece of wizardry that you just paste into your app and never touch again. It's essentially write-only software. And that's not a fault of FFmpeg necessarily. It is a domain that is just very complicated. There's a lot of need for performance. So you need a lot of kind of tightly written software, and it all gets really messy. What Membrane does is it takes this wizardry and it breaks it apart into discrete components that you can then put together into pipelines that are very flexible and let you do almost anything that you want. And actually, we should enable the waveform. Happens. So the way Membrane does this is that sometimes it does it in Elixir. Every single element is controlled from Elixir, but sometimes they also talk with FFmpeg through NIFs. Sometimes they use other libraries, whatever is necessary. But they break apart the media processing process. And it is built for live streaming, so they tackle a very hard problem first. Live streaming is a very difficult problem. It's a very annoying domain. Live requires low latency. Live requires robustness. Those are Beam traits. So taking the Beam seems like a pretty good idea, and then building on that. And by trying to solve for this really hard problem, they built a framework that is very flexible and capable of many other things. Primarily really cool and really dumb experiments in my eyes. So, for example, you can work with things like time elapsed and the progress. You can do things like measure audio levels and indicate them, or even creating waveforms. Actually, we could bring out the fancy waveform. No, the fancy waveform. Thank you, Whisper. You can do things like slice out particular images. You can cut out small pieces of video. You can mute, you can delay, you can bleep. There's so many things that people should be building with it. It is also fully cool theory compliant. It has inputs called sources, it has outputs called sinks, and it has transformations called filters. Now, let's unpack transformations a bit. So, in many cases, if you just take some input data and you output it in a different place, you're just shuffling data around. Sometimes you need to do that, but it's not particularly interesting. Most of the time, though, you need to take multiple inputs and you need to synthesize some new interesting output, or you need to transform it significantly. So there are transformations that are quite easy, like taking a piece of text, cutting it down, just truncating it, or taking an image, scaling it down, or maybe taking some text and putting it in an image and then doing something with that. Well, at that point, you start to need a special library. I would recommend the Elixir image library. It's really cool. It does a lot of fun stuff. And Membrane, of course, allows us to do this for audio and video. It's more complicated than images for sure, but it does allow us to do it. Now, there is a new way of dealing with unfriendly formats. Actually, there's a new way of transforming unfriendly formats, because if I don't say the exact right thing, it will not move forward. If it hasn't been obvious, you can't have a conversation right now without talking about ML. I'm very sorry, but that's the case. Beyond the hype, like I'm not a big ML enthusiast, but there are some undeniably useful utilities in these models. Particularly this kind of weird world of math allows you to deal with some really messy formats, particularly human speech comes to mind, and turning that with some reasonable degree of accuracy into text. But there are other kind of utility models that we sometimes take for granted and sometimes don't know about. So OCR, grabbing textual information out of an image. Or face detection, which can, of course, allow you to kind of crop in on a face in an image, which can be really nice. Or you can play around with adding filters to landmarks and faces. Or you can bootstrap your surveillance state, which can also be, I guess, neat. There's also this weird thing with turning textual descriptions into actual images. So this is the stable diffusion thing. It has very low accuracy in terms of achieving the result you want, but it is fundamentally capable of doing that, and that's kind of interesting. Now, you can absolutely get access to all of these things through the original tooling. So machine learning requires fast tools, fast languages, and a bunch of math. And I stick to the kind of pre-trained open source models that I can actually understand. Because I want to build things. I'm not here to particularly learn all the math. And I've done that through Python, just shelling out to Python. I used to be a Python developer, it's fine. It's not a particularly great experience, but it's doable. You can do it when you need to. But this brings us to Bumblebee. Because Bumblebee takes the promise of numerical Elixir, NX, and it makes it much, much easier to use. So you've already seen examples of this, but they launched with Stable Diffusion, GPT-2. They've added more things, like, for example, Flan T5. I know Sean Moriarty is working on Llama, so I guess we're getting large language models as well. For this talk, I'm obviously using OpenAI's Whisper. It is one of the most useful models in my eyes, especially since it makes actually accessibility more accessible. Because it's really hard when you're doing a lot of audio and video, like I am, to actually transcribe all of it. That's not something I do, but it becomes possible now. I should also mention evision. So those are the OpenCV bindings by Coco. Super cool project, super useful, and actually, if I lean back a little bit, I might actually find my face. Hey! Surveillance data. But it also allows you to do things like super sampling for upscaling images. It allows you just the whole slew of OpenCV features. And if you've ever looked into OpenCV, it can do a ton. There's also a ton of machine learning models in there. All right, slide forward. All of this stuff has a lot of complexity to it, and most of these tools are about managing that complexity. We have the fortune of running on the Beam, and if you're working with the Beam, you usually don't need any extra infrastructure, which is nice. Sometimes you need to put it on a server, but that's about it. So we're doing media handling. It's well abstracted. It's very flexible and powerful. We're getting machine learning, also well abstracted, and without knowing any of the math and without understanding the models too much. We're doing live web UI, also well abstracted, with a ridiculously small amount of code. And we get communication and coordination between these things with a kind of high-level standard method. We have message passing, Beam things. Fundamentally, this makes hard things easier, which pushes the boundaries of what is cool and what is challenging. And I think the Elixir ecosystem is kind of uniquely positioned to do that. You can see a cool startup like Supabase take the capabilities of Phoenix and sell them to ecosystems where like real time is actually difficult. Okay, good for them. That's a good idea. You should try it. But fundamentally, I think Elixir as an ecosystem has this capability of building high-level abstractions for really complicated things, partly because we are building on top of Erlang and the Beam, which are high-level abstractions for really complicated things. but also because we have a kind of cultural willingness to push boundaries and try things that couldn't work elsewhere. And that's an interesting thing. So if you try to do something the industry standard way, you risk lowering yourself to that standard. That's not really that cool, is it? So I guess most of you have figured it out, but like this presentation itself is a little bit of a cool software experiment in my eyes. Actually, it ceased being cool a while back because I've been working on it for a bit. But I'm trying to demonstrate a case of taking multiple inputs, transforming them, and producing some fun and interesting outputs. So let's look at what this presentation is actually doing. Let's unpack this presentation a bit. No, whisper, come on. Slide forward. I could not script this. Okay. So we are measuring audio levels, and we are taking that, we're getting those as messages. We're sending them on to a LiveView, and the LiveView is turning it into an SVG. That's what you're seeing scrolling past on the screen. I'm actually doing a stupidly complex variant in enabling and changing the waveform. So if I say disable waveform, it goes away. And because of who I am as a person, it's not just a flag that's getting set. I actually recompiled the module that renders the SVG, because we can do that on the beam, okay? We can change our entire application at runtime, and I think we should experiment with that more. Now, but we measure those audio levels, we produce the waveform. We also do live transcription, poorly. And we do one low latency, kinda near instant, poor quality transcription. You see that pulsing. That's using a 1 second chunk of audio, which gives very little context to make the right call. Then there's a slower but better transcription, and that uses a 5 second chunk of speech. And we use that transformation from audio to text to implement voice commands. These are not really that complicated because it's essentially like string contains. This is all running on a CPU. It has no active cooling. It's a lightweight laptop. If I was running it at my workstation at home, actually I gave this talk at a remote meetup, or a previous version of this talk at a remote meetup in Krakow, and then I could do it from my workstation. I could use a much, much better version of Whisper. So you get these models at different levels, and I have a solid GPU in that machine. This is the tiny one. I'm doing occasional face detection using evision, and whenever it detects my face, it will draw that rectangle and put it on the screen. The rectangle is also SVG. Now everything is just messages to LiveView, updating the state, pushing it to the client. It's the same thing anyone using LiveView is doing. It's just a matter of what are the inputs, what are the transformations, and how do I make the output interesting. Fundamentally, it's parlor tricks mixed with a bunch of potentially pretty useful stuff. I hope that, if anything, you take away from this talk is just a sense of possibilities. There are a lot of cool inputs out there. There's a surprising amount of potential transformations these days, and there are a lot of ways to produce an interesting output. And the trick after that is just creatively bashing things together over and over again, building a muscle of creativity and creation until cool becomes effortless. Thank you for your time.